Welcome to my series on calculus. In this video, we'll discuss equations of tangents and normals, and we'll have few applications based on it. Here, I'm sharing with you 5 questions from previous test papers. Question number 1. At what point is the tangent to the curve x plus y square equals to 1 parallel to the line x plus 2y equals to 0? Question number 2. The line normal to the curve y equals to x square minus 3x plus 5 at point 35 intersects the curve at another point. Find that point. Question number 3. A speeding driver trying to drive along a road modeled by the curve f of x equals to 3 over 2x minus 1 leaves the road curve at the point x equals to 1, traveling in a straight line in the direction of the tangent. Will the driver hit a tree located at the point 2 minus 3? Explain. Question 4a. The tangents to the curve f of x equals to x cubed minus 6x squared plus 11x minus 6 at a 1 0 and b 2 0 meet at point C. Find the area of the triangle ABC. A variation to question 4a is question 4b. Question 4b is the tangents to the curve, same curve, at a equals to 1 0 and b is this time minus 1 minus 24 meet at C. Find the area of the triangle ABC. You can always pause the video, answer these questions, and then look into my suggestions. So let's begin with the very first question, which is at what point is the tangent to the curve x plus y square equals to 1 parallel to the line x plus 2y equals to 0. So we want parallel to x plus 2y equals to 0. That means what should be the slope? Let's rearrange. So we get 2y equals to minus x, y equals to minus half x, right? So the slope m should be equal to minus half, right? So that is what we are looking for. Now let's find the derivative. We have x plus y square equals to 1. We can do implicit differentiation, differentiating with respect to x on both the sides. We get d dx of x plus d dx of y square equals to d dx of 1. Now that is 1 plus this is 2y dy dx and this is 0, derivative of a constant. So from here we can write dy dx is equal to minus 1 over 2y, right? So that is the derivative at any point on the given curve. Now what are we given? We want these two should be same, right? We want this slope should be same as minus half, right? So we want that the derivative dy dx should be equal to minus half, but we know it is minus 1 over 2y, right? So clearly that gives you that y equals to 1, right? Now if y is 1, what is the value of x? We have the equation x plus y square equals to 1. So this is what we got. Let's sub 1 here. So we get x plus 1 equals to 1. That means x equals to 0, right? Therefore, point is 0, 1, correct? So that is how we are going to solve this particular question. So I hope all the steps are absolutely clear. Now let's take question number 2, which is the line normal to the curve y equals to x squared minus 3x plus 5 at point 35 intersects the curve at another point. Find that point. So basically this is a parabola. So think about it like this. We have a parabola here, and the vertex will be at minus 3 by half, which will be somewhere minus of this, so on the left side of 3. So we are looking for a tangent at this point somewhere here. So as you can see, that is the point, let us say 3, 5. The line normal to this curve at this point, so normal will be kind of like this, right? So it intersects somewhere else. We need to figure out this point. So I hope you understand the question. Now let's find the slope of the tangent first. So we are given y equals to x squared minus 3x plus 5 dy dx equals to 2x minus 3. Now dy dx at x equals to 3 will be 2 times 3 minus 3, which is 6 minus 3, which is 3, right? So the slope of this line m is 3. So slope of normal will be what? Slope of normal, that is m perpendicular, will be negative 1 over 3, right? Okay, so now let's find the equation of normal, right? So now let's find equation of normal. Now since slope is 1 over 3 and it goes through the point 3, 5, we can use y minus y1 equals to m perpendicular times x minus x1. So we have y minus y value is 5 equals to minus 1 over 3 x minus x value of 3. So if I cross multiply, so I get 3y minus 15 equals to minus x plus 3, right? So we cross multiplied, bringing x on the left side, or we need to find point of intersection. Let's isolate y, right? So we have 3y equals to minus x plus 3 plus 15, right? So that means 3y equals to minus x plus 18, or y equals to minus 1 over 3x plus 18 over 3, or value of y is minus 1 over 3x plus 6. So we get the value of y, rather the equation, as y equals to minus 1 over 3x plus 6. So this is the equation of normal, right? Now let's find point of intersection of normal and parabola. So what we are going to do is we'll substitute this y value, which is minus 1 over 3x plus 6, into the equation, which is x squared minus 3x plus 5. And then we can find the value of x, correct? Okay, so bringing all the terms together, we have x squared minus 3x plus half 1/3 x plus 5 minus 6, right? X squared equals to 0. We brought all those terms to the right. So this becomes minus 9 plus 1, which is minus 8 over 3x. And here we have 5 minus 6, which is minus 1 equals to 0. So that's what we get. Now we can actually calculate the value of x using quadratic formula. We could just multiply by 3 also. So and then also figure it out. So because 3 and 3 is 9, minus 9 and minus 8, we could solve better, right? So let's multiply by 3. So we get 3x squared minus 8x minus 3 equals to 0. So we are looking for a product of minus 9, right? And sum of minus 8. So we could write this as minus 9 times 1, right? So we could write this as 3x squared minus 9x plus x minus 3 equals to 0. Factor 3x. So we get x minus 3, and we have x minus 3 here equals to 0. X minus 3 is common, and we get 3x plus 1 equals to 0. So from here, definitely x equals to 3 is already given to us. That's correct. The other point is minus. So that gives you 3x plus 1 equals to 0, implies that x is equals to minus 1 over 3, correct? Right? And this gives you x equals to 3. So these are the 2 points. One is, of course, the point of tangent also. So the other point should be, we can substitute the value of x as minus 1 over 3 and get the value of y. So y should be equals to minus 1 over 3 times minus 1 over 3 plus 6, which is 1 over 9 plus 6, or is equal to, let's push the page a bit more. Okay, so that gives you 9 times 6 is 54 plus 1, 55 over 9, right? And therefore, let me write down the answer here, that the point should be minus 1 over 3, 55 over 9, right? So that is the other point. Is that clear to you, right? So that is how we are going to find the point of intersection of normal with the curve. Now let's take up question number 3. Here is question number 3. A speeding driver trying to drive along the road modeled by the curve f of x equals to 3 over 2x minus 1 leaves the road at the point x equals to 1, traveling in a straight line in the direction of the tangent. Will the driver hit a tree located at the point 2 minus 3? Explain. So at x equals to 1, he leaves the road. Let's find the y value at 1 first, which would be 3 over 2 minus 1, or this is just 1, is 3, right? So at 1, the value of y is 3. Okay. So in fact, he leaves the road at a point, let's call this point P, at 1, 3, right? Now we'll basically find the equation of tangent line. So let's find slope. So the derivative at x will be, this can be written as, you can write this as like 3 times 2x minus 1 to the power of minus 1, right? So the derivative is minus 3, 2x minus 1 to the power of minus 2, and derivative of 2x is 2, right? So we get this as minus 6 over 2x minus 1 whole square, right? Or you could apply the quotient rule, right? So either way, it could be done. So that becomes the derivative. Now, let's find the slope of this tangent line at x equals to 1. So the derivative at 1 will be minus 6 over 2 times 1 minus 1 whole square, which is minus 6 over 4 minus 1 is 3 square. So which is, you could write this as one of the 3's goes, so it gets 2 over 3, minus 2 over 3, right? So it is 6 over 9, which reduces to minus 2 over 3. So that becomes the slope. Now, we know that the point is 1, 3, and the slope m is minus 2 over 3. Let's find equation of the line. Equation of the line would be y minus y1 equals to m times x minus x1. Clear? So we get y minus 3 equals to the slope, which is minus 2 over 3 times x minus 1. Or 3 times y minus 3 equals to minus 2 times x minus 1 3y minus 9 equals to minus 2x plus 2. Bringing it together, we get 2x, or okay, we can actually isolate y also, right? So let's bring it here, 2x plus 3y, this number on the other side, 2 plus 9. So we have equation 2x plus 3y equals to 11, right? So that becomes the equation of our tangent, right? So this is the equation of tangent line. Now, if the point lies on it, so now let us check. So that is the equation of the tangent line. Now let us check if this point lies on this line or not, right? So let's check for point 2 minus 3. So on the right side, we'll substitute 2 and minus 3. We have 2x plus 3y. So we have 2 times 2 plus 3 times minus 3, which is 4 minus 9, which is minus 5. Since it is not minus 3, it is not minus 3, it is minus 5, right? So therefore, the driver will miss the tree, right? So driver will not hit the tree, not hit the tree. Is that clear? It will go through the point minus 3, right? This is 2 minus 3. Since if I substitute 2 and minus 3 in my equation of tangent, it doesn't meet, right? We didn't get 11 on the right side. So I hope that is clear. So it is not going to hit. Now let's take up question number 4. The tangents to the curve f of x equals to this at a minus 1, 0 and b 2, 0 meet at a point C. Find the area of the triangle ABC. Now this is a very interesting question. We have a cubic function. We are already given two x-intercepts, right? So it is which are at 1 and at 2, right? So think like this. Let's make a rough sketch here. So the cubic function has 2 zeros, right? So these are the 2 zeros, 1, 0 and 2, 0. So let's say we have a function which is kind of like this. Right, so at least we know this part. Well, that is a portion of the graph. Okay. So these are the 2 points where the function is crossing the x-axis, 1 and 2. We don't know about the other part. We are assuming that since this is x cube, right side will be up. So somewhere it is going to turn and go that side. Okay. So a portion of the graph has been shown here. Now the idea here is that we need to find area of the triangle ABC. A and B, the points are given to us. This one is A, which is at 1. At B, this is at 2, right? And tangents meet somewhere. So if I draw a tangent line, so let me just sketch one tangent here, one tangent there, for example. This point is C for us. We need to find area of this triangle. That is what the question is. Clear? Okay. So let's find equation of both the tangents and then the point of intersection. So the function given to us is f of x equals to x cubed minus 6x squared plus 11x minus 6. Derivative of this function is 3x squared minus 12x plus 11. Now derivative at x equals to 1 we'll substitute 1 here. We get 3 minus 12 plus 11. So which is 2, right? And derivative at 2 will be substituting 2 here. We get 3 times 4 minus 12 times 2 plus 11, which is 3 times 4 is 12, and 12 plus 11 is 23. And here we have 24 minus, so it's minus 1, right? You can actually use calculator also. Let's use calculator. We have 3 times 4 minus 24 plus 11, right? Which is minus 1. So we have both the slopes and we have both the points. So let's find equation of these lines. Okay, so we will say equation of line 1, where the point given to us is 1, 0 and slope is 2. Then, this is the point A. Let me write A here, right? And then we have B, which is 2, 0, and the slope is minus 1. So that seems to be the kind of situation. So we can write this equation as y equals to 2x plus b, 1 and 0. So 1 here and 0 there. So we get 2 plus b. So that means b is equals to minus 2, or the equation is y equals to 2x minus 2. In this case, we get the equation as y equals to minus x plus b, 2, 0. So 0 equals to minus 2 plus b. So 2 is equals to the value of b. So the equation will be y equals to slope of minus, so minus x plus 2. Right. So these are the two equations. So equation of one line here is this one is let's say minus x plus 2, and equation of the other line is 2x minus 2. Now let's find the point of intersection between these two lines. So we say point of intersection. The two lines are y equals to 2x minus 2 and y equals to minus x plus 2. So if I subtract, I get 0 equals to 3x minus 4, or 4 over 3 is the value of x. So y value is going to be what? Let's substitute 4 over 3 here. Minus 4 over 3 plus 2. So y value will be minus 4, and that is plus 6 over 3. So y is minus 2 over 3. Sorry, plus 2 over 3. Correct? So we get the value of y as 2 over 3. Okay. So we had these two equations, one which is y equals to 2x minus 2. The other one is y equals to minus, we put this minus here, 2 and 0. Okay, so y equals to minus x plus 2. So 2x minus 2 and minus x plus 2, when I take away one from the other, we get 0 equals to 3x minus 4, x equals to 4 over 3. Substituting 4 over 3 in the second equation, we got minus 4 over 3. 3 times 2 is 6, which is 2 over 3, right? Okay, so the point C is basically the x value here is 4 over 3 and the y value is 2 over 3, correct? So we got the point C. Now we need to find area of the triangle. So area of triangle ABC. This is A, right? So we know the area of the triangle is half base into height. So in this case, we can clearly see that height is the y value, right? So that is the height, 2 over 3, correct? And the base is 2 minus 1, which is 1, right? So in our case, it is half of 1 times 2 over 3, and that gives us a value of 2 to cancel 1 over 3, right? So we have to take always the positive value. So we get 1 over 3 unit square as the area of this given triangle. Is that clear to you, right? So that is how we are going to find area of the triangle. Now this was simple. This was simple since we had the x-axis with us, right? So whenever it is along the x and y axis, it becomes simpler because the vertex gives you the height directly, right? So in this triangle, we know base equals to 2 minus 1, which is 1, and the height is the y value, which is 2 over 3 units. Is that clear to you? So we found it. So I hope you understand all these steps. You saw how we found equation of both the tangents and then their point of intersection. We had a triangle to find area with. This was relatively a simple case since we had the 2 points on the horizontal x-axis. Well, even if we have those 2 points on y-axis, it is simple. It becomes difficult if the point is not on the x-axis as we have in part B. I would like you to explore and find the solution of question number 4b. Take it as a test. On the whole, I hope you got fairly good idea about how to work with tangents and normals. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.